Hi everybody, in this free 10-minute video tutorial, I will show you how to check if your dataset is balanced. When developing your own AI applications, it's important that your dataset for both training and testing is balanced. For classification tasks, balance means there are roughly an equal number of samples for each of the different classes in the dataset. We will quickly review the motivations for why balanced datasets are important and then code the dataset balance checker from scratch using Google Colab. If you're watching on YouTube, you can also follow along the tutorial by clicking on the link below the video. Let's get started. Let's imagine you're building an AI program that detects cats or dogs in an image. You decide to use a test dataset consisting of 100 photos, 10 cats, and 90 dogs. And instead of building a really sophisticated neural network to accomplish this, you decide to build a single line function that instead returns dog for any image that is given. If you were to now test your image analyzer on this unbalanced dataset, you would find that it actually is 90% accurate. Now, 90% accuracy is normally really good, but the problem here is that we're using an unbalanced dataset to test our image analyzer. Now instead, if we used a balanced dataset where we had roughly an equal number of cat images and dog images, we quickly find out that our accuracy on this particular image analyzer is only 50%. That is as good as flipping a coin, which is really, really bad. So hopefully now you have an appreciation for why we need balanced datasets. Let's now take a look at how you build the code to verify that the current dataset you're working with is balanced. All right, so to get started, I'm gonna head over to Google Colab. If you haven't used that before, you can always try our Google Colab free tutorial on leaky.ai, but you can also just continue and follow along with me. When you get to Collab, you can just click New Notebook. I prefer the dark theme, which is why this looks the way it does. Maybe look a little different for you. Make sure you're logged in. And the first thing we're gonna do is just connect to a backend here. So I'll click connect. And the great thing about Google Colab is you already have all the PyTorch libraries loaded for you. So we just need to import them. So to start, we'll import PyTorch. And then we also need the dataset from Torch Vision. So you can just say from Torch Vision, go ahead and import datasets. All right, and then we can execute that. Just insert another code cell by going insert code cell. And then what we can do is we can just start building our check balance function. So I'm just gonna call it check balance, and I'm gonna give it a dataset and also the name of the dataset just to make maybe the printing a little bit better. And the first thing we're gonna need to know is what are the class names inside of this dataset. So this dataset will have, say, for example, dog, cat, or have a lot more distinguishing names. And we can grab that from the datasets classes. It's called classes here. And that's sort of the list of different class names that the dataset contains. And to get the total number of classes in the dataset, we can just call length on that. So this is the total number of unique classes. And then what we're gonna do is we're gonna count how many times each of the classes have been used. So if there's an image, say, of a dog, we're gonna increment the dog class. If there's an image of the cat class, then we're going to increment the variable holding the number of cat classes. And so to build a simple array like that, we can just we can call it, say, for example, total per class, and we can start each item with 0, and then we just multiply that by the total number of classes. So these are the kind of the first 3 variables I'm gonna use, and then I'm just gonna create now a loop to count all the different classes. So to do that, I'm just gonna iterate through the dataset. And what's wonderful about the dataset class object is when you call it, you will get the input, which we don't need, which is gonna be the image, and then the target class, which is the label. For this particular pair, so the input and the desired output. And so once we have the desired output, we can just increment our tracker above effectively by indexing using that target class. And then we just increment by 1, right? So here, I've gone through the entire data set, and every time I'm going to grab the output, which is the target class, and then I'm just going to increment my total per class array for that particular class by 1. So at the end of this, this array will hold all the different classes and the number of times they occurred. So now I can go ahead and print out the results. So maybe what we can do is we can print out, say for example, the name of the data set and how many total instances there were in this data set. In other words, how large the data set was in total. So we can say, for example, we can sum up over the total per class variable. So that will just give us, the size of the data set here, and then the name of it. So we have kind of a sense like, were there just 100 instances in the data set, or were there 10,000 or 100,000 instances. And then what we can do is we can kind of iterate through each of the different classes and just print out how many instances were found of each class. And so to do that, I just need to iterate through the array that we created. And so I can do it this way per class. And this way I get the index, which is basically the class ID, and then how many instances were found. And then to print that out, I can just quickly print those. So to do that, I'll print the class sum, followed by say for example, the class names, just so we know what class name that was. And then I can also print, what I like to do is I can print the percentage that this class is represented in the data set. So if I have 2 classes, I like to know that each class is roughly 50%. So to do that, I can just divide the class sum by the total number, right? So I can just sum it up again, total per class, and then I just multiply by 100 to get obviously the percentage. And to make it a little bit prettier, I can just reduce it down to 1 decimal. So hopefully that should be about right. Make a little percent sign. All right, good. So that gives me the number of times this class was found in the data set, the name of that class, and then the general percentage that number represents over the entire data set. So hopefully that will help me very quickly see how balanced the data set is. So now I can go ahead and execute this code, and I have built this check balance function. So now I can load a data set. So in this case, what we'll do is we'll load the MNIST test data set. So we'll just call it test, and to grab it, you can just call datasets, and it's MNIST, and you're going to give it first, a directory, so you can call it data, and then we want the test data set, so we can just set this to false. So train is equal to false, and then we're just going to download it, so that's equal to true. All right. So what this will do is just download the entire MNIST test data set and put it into test. And we can just go ahead and run it, and you'll see the download kind of occur, and it's automatically downloaded for you. And now once we have that, we can go ahead and check how balanced it is. So call our function, pass in the test data set, and then we'll say test data set, the name. And then when we execute this, we see the results here. So in this case, the MNIST test data set had 10,000 entries. And the MNIST dataset, if you're not familiar with it, has a bunch of handwritten digits. So it has a bunch of digits for 0, a bunch of digits for 1s, and so on and so forth, down to 9. So there's 10 unique classes. And here you can kind of see the rough balance for each of them. So overall, this test dataset is pretty balanced. At the high end mark, you have about 11% of 1s. And then, for some of the smaller ones, you have maybe 9.6% of 6s. So this is a pretty good balanced data set. We could also load a different data set. So by going up here, we can just load the fashion version of this. So this is instead where you have a bunch of pictures of, say, different articles of clothing. So here we'll download the fashion data set. And once we run that, we can run it, since we called it test as well, we can just run this code again. And here you can see the test data set of fashion MNIST has 10,000 entries, and in this case, it's exactly balanced. There are 1,000 instances of each of the different classes. So this is a really good data set to use because it's highly balanced. And so you won't run into any of the kind of issues that you learned about earlier in the video. If you found this video helpful, please hit the like button at the bottom of the video and subscribe to our channel. This will give you notifications when new free AI tutorials become available. If you want to learn more, head over to leaky.ai and check out all our free AI programming tutorials. We also have an amazing Introduction to AI Programming with PyTorch online class where you'll learn all the basics you need to start developing your own AI programs. In the course, you'll complete several projects, building your own car performance analyzer, and also a state-of-the-art vision detector that can distinguish between different types of flowers. The course is fully self-paced and completely online and can usually be completed in about 4 weeks. If you want to learn more, check out the link below the video for the course overview. Finally, subscribe to our free email list where you'll get updates on when new tutorials become available and also information on some of the latest AI trends. Thanks for watching and happy learning.